Assalamualaikum. Today we will solve a problem about if any vertical plane surface submerged under any kind of fluid, then what type of hydrostatic force will work upon that surface and where the pressure of center will act. Let's see a problem about this topic. Here in the question they said that a room in the lower level of the cruise ship has a 30 centimeter diameter circular below. Means suppose this is any sea water or any kind of fluid where a cruise ship is going, and this is the upper portion that is upper from the water, and from here our sea level started, this part under the water, sea water. So here said that the lower level, this two circular below, this two window has 30 centimeter in diameter, and if the midpoint of the window, means this is the midpoint of the window, is 5 meter below from the watery surface, this is our starting watery surface. So this midpoint, the distance between the midpoint and this watery surface is 5 meter. This is given in our question, and now we have to determine the hydrostatic force. We have to find out that hydrostatic force acting on this window, means a hydrostatic force will work upon this window as this is submerged under this fluid. So a force will work upon this window, that force will exerted by this fluid. So we have to find out this F, and the pressure center, means where the pressure, we know that at the point of pressure center, suppose this is the pressure center of this window, and we know that all hydrostatic force will work on this specific pressure center. So we have to find out this pressure center. Now let's solve this problem. First we will find this hydrostatic force. So if we want to this hydrostatic force, we know the formula of hydrostatic force, which is H rho G, and as this is any circular shape window, so the centroid must be at the center of this circular shape. So we will take the H, which is the difference between the watery surface and the centroid, which is 5 meter. So here H will be 5 meter, and rho, here the given is take the specific gravity of seawater is 1.025. So here given the specific gravity, we know that specific gravity is equals to the density of that fluid which we want to find out the density. Here this is seawater, and divided by density of normal water, that is under 100 degrees Celsius, 4 degrees Celsius, which is 1000. So we have to find out this. So the density of seawater will be specific gravity into 1000. Here the specific gravity is 1.025 into this 1000, which is 1025 kg per meter cube. This is the unit of density. As we have to find out the force under this fluid, so here we have to use the density of this fluid, which is 1025 kg per meter cube, and we know the value of G. So if we put this value 5 height into 1025, which is density, into 9.81, which is equals, sorry, here we have a mistake. This is the formula of pressure, and as we are finding the pressure force, hydrostatic force, so we have to multiply this pressure into area, means the area of this circular window. As this is in circular shape, so the area will be pi r square. So pi into, in the question there is given the radius of this, diameter of this window is 30 centimeters, so the radius will be 15 centimeter. So we'll convert it into water square. Answer will be 0.7065 meter square. So we have to multiply that here, 0.07065, and our ultimate answer 3552.017 Newton. So this is our required hydrostatic force that working upon this window. And now we will find out the center of pressure, means where, at which point all this hydrostatic force will work. Suppose this is that point, here our hydrostatic force will work, and we have to find out this distance from the sea level to this point. Suppose this is H star. So we have to find out this H star. If you see my previous video, here I have already proved that for any vertical plane surface submerged under water, the distance between the pressure center and the surface will be this. This is the formula. So here I will use this formula. This is the formula of finding center of pressure. Here H bar equals to the centroid of this object. As this is the circular shape, so the centroid will be at the center of point, which is 5 meter. That is our H we have used in finding the force. And A will be the area of this window, which we already find out. And this Ig, this is the moment of inertia about the center of pressure. So what will be this Ig? This is in circular shape. For circular shape, we know that the moment of inertia will be pi divided by 64 into r to the power 4. This formula is, we have to memorize this some formula for finding this Ig, and it will vary with the shape. So for this case, pi divided by 64 into r equals to 0.15 whole to the power 4. So this is the moment of inertia, and we will put all these value in our formula. So Ig equals to 3.976 into 10 to the power minus 4 divided by A is this 0.07065 into height, means the distance between the sea water and the centroid, which is 5 plus 5. So the answer will be 5.001. So in all cases, the center of pressure and the point of gravity centroid will not be the same. Here the centroid is under the 5 meter from above, and the center of pressure is 5.001 meter. So this is how we can easily find our required solution. I hope you understand. Thank you.